Good morning, all of you. Now we can have a summary of the topics of Unit 6. Unit 6 is jigs and fixtures. So jigs and fixtures, if we try to look at it, we should understand that jigs and fixtures are special purpose tools which are used to facilitate production. That means they will help in production. They are going to help in production. Whenever work pieces are produced on a large scale. Please understand that here mass scale doesn't mean that it is mass production. It is actually a batch production, but the batch is of sufficiently large size. And please understand that these jigs and fixtures are special purpose tools. It is opposite to general purpose tools. Hmm. So opposite, it is opposite to general purpose tools. These are not general purpose tools, rather they are special purpose tools. That means they are used for particular type of product or products. Once their use is over, you have to stack them up, and again when a use arises, you have to bring it back, use them and store them. So jigs and fixtures are nothing but special purpose tools. So there are many advantages when we go for use of jigs and fixtures. Their use is going to reduce the cost of production, because leaving out work of the job as well as setting up of tools is reduced so much. They increase the production rate. They provide high accuracy for parts. They provide interchangeability, reduce quality control expenses, increase versatility of the machine tool. They help the use of directly less skilled labor, or they help in automating the machine tool, improve safety, reducing the rate of accidents. Right? These are the advantages of jigs and fixtures. Advantages of jigs and fixtures. Next, uh, when we look at the jigs and fixtures, what are the basic parts and what they actually mean? Let us see. So jig is defined as a device which holds and positions the work, locates and guides the cutting tool relative to the workpiece, and it is not usually fixed to the machine table. It is lighter in construction. On contrary, this fixture is a work holding device which can only and position the work. It does not itself guide. Right? So the basic difference between the jig and fixture lies in that jigs have a guiding function. So they have a guiding function, whereas the fixtures do not have a guiding function. Instead, they have setting function. Tool can be set to move in a particular way using slip gauges or any standard reference devices. So we may understand that jigs and fixtures, they should definitely have some important parts. What are the basic parts? One, it is the body. Two, locating element. Three, clamping element. Next, four, guiding elements or setting elements. Five, elements for positioning or fastening the jig or fixture body on the machine where it is used. So these are the basic components. So one may understand that jigs, they will be used in cases of drilling, reaming and all hole related operations. On the other hand, the fixtures can be used with turning, milling, grinding, shaping, planing, boring, as well as assembly. Likewise, they can be used for indexing and welding also. Right? So these are the applications of jigs as well as fixtures. Now let us look to the each of these basic elements. So it should be made of a rigid body. Of course, this we are not going to discuss in detail. It may be a plate, box, or frame, right? Which contains the remaining elements. Let us see the remaining elements. So among them, the first important element is the locating element. So you can look a prismatic body which is in space. A prismatic body in space has totally 12 degrees of freedom. Among them, 6 are translational degrees and 6 remaining and 6 more are the rotational DOF. So that is when I mean by degrees of freedom, I should understand that how a body can move. That means it can move in positive x direction as well as negative x translation. Similarly, YY translation, ZZ translation, rotation clockwise, anti-clockwise about each of these axes. So these are the degrees of freedom. So when I require to perform any operation, any measuring operation or any activity on the workpiece, I should securely seat the job. So for that, I should see that the body is located inside the jig or fixture body in a proper manner. So this establishment of a proper relationship or positioning, I may use the word positioning. So what I do is I position workpiece in the jig or fixture body. So this I can mean by the term locating, right? So when I position it, I can do a particular operation on the workpiece, right? So once a body with so many degrees of freedom is found, we have to arrest as many degrees of freedom as possible so that the body is properly seated, it will not move and it will be constrained so that the required operations can be performed with ease. Definitely there are some principles of location. That means location has to follow some principles, right? The first and foremost principle is the 3 to 1 principle or the 6-point location principle. You can find that a prismatic body can be pushed into a corner. One it is the floor, the remaining two you can understand them as walls. So this is floor, so this is wall 1 and this is wall 2, right? Now the body is properly located. Let us see what are the degrees of freedom arrested by the presence of these 6-point locations. So the pin F alone, it will prevent translation in x direction towards the wall, right? So totally 3 translations and 6 rotations have been stopped, or altogether 9 DOF are stopped. So in addition to this 3 to 1 principle, definitely the location system should satisfy a few more principles. One principle it is principle of mutually perpendicular planes, where we can find that the 3 planes which we see here, wall 1, wall 2 and floor, they are mutually perpendicular to one another. What happens if they are not kept perpendicular to one another? There are likely to happen some type of problems. What are those problems? First one, it is the workpiece will tend to lift up due to wedging action. This next one is a large amount of error is introduced, which we call it as cosine error. Right? So this is the second principle. The third principle, which we call it as principle of extreme positions. What is this principle of extreme positions? We should note that in the pin location or any other location system, the locating devices, say the fouling devices which we see here, 3 pins. So these 3 should be located as far as possible. So that is known as principle of extreme location. Right? Next we shall look to the locating devices. So there are different type of locating devices. The pins which we have seen previously in our examples for studying about the degrees of freedom and 3 to 1 principle. So we call them as support pins or support pads. Likewise, there are called pins, locating pins, jack pins. So we shall see each of them. So this is a post. We call this as a post, P-O-S-T, post. And this is a pot. So workpiece is located inside a pot, while post is located, or post external surfaces are going to touch the workpiece internal surfaces. So whenever we are having finely removed holes, when we have finely removed holes, it is better to have the post or pot. So we call them as cylindrical locating pins. So preferred, we can write here, preferred when workpiece has cylindrical removed holes. So the whole internal surface or the workpiece external surface is used for location. Next, support pads. So they simply have a flat surface. You may understand that workpiece rests on the flat surface. So this is a flat surface. So it's a flat surface over which the workpiece rests. Right. So this is a support pad or support pin. This support pad may be fixed type or adjustable type. Right. So adjustable with the use of a bolt and nut arrangement, or adjustable with the help of a knurled screw. And likewise, we have jack pins. So jack pins have the possibility of adjusting the height. So I can set the workpiece at a particular height, or the workpiece is made to rest on the pin over springs and stay in that position. So staying in that position, or position which you want to have it, you can tighten the bolt and lock it in the position. Right. So these are three types of locators. Still, there is one more type of locator, which we call it as radial locator. What is this radial locator? So radial locator, you can understand that by looking to this example. You can find a workpiece located with the help of cylindrical pins. So you find pin A, pin B, pin A, pin B. So imagine that pin B is of full diameter and it has got perfectly seated in the hole. Now what happens to hole A? So what should be the way we should stop the movement of the workpiece? So first we have to see what are the degrees of freedom that have been stopped. If you look to the DOF stopped, pin B is going to stop XX translation. Likewise, it is going to stop YY translation. Next, the top surface of the jig or fixture body, it is going to stop some degrees of freedom. So Z downwards, XX rotation and YY rotation. So we find remaining some freedoms or degrees of freedom are left over. Z translation one side. Likewise, Z translation to Z rotation is also remaining. So rotation about pin B, right? So that means Z rotation about pin B has to be stopped by pin A. That should be the only one A should do. Otherwise, we call it as redundancy. So pin A is called as radial locator and the location is called as radial location. If pin A is a full cylinder, it will try to stop the same device which pin B has already stopped. So this condition is called as redundancy and the locator is called as redundant locator. What is the remedy? Go for usage of incomplete cylinder, which is called as a flat end locator or diamond pin. So you can find the diamond pin in this place. So in the case of diamond pin, you can find that the gap between the hole and the pin ends is more in one direction, while it is various in other direction. So such a type of locator, we call it as diamond locator, right? Next, V location. So when I mean by V location uses uh, V blocks or V shape of surfaces for locating cylindrical surface. So the one advantage with V is even the dimension of the workpiece is going to change, still its support is good. Next, we shall talk about the additional principles. So previously what we have seen, the 3 to 1 principle of extreme positions and mutual principle of the mutually perpendicular planes. They are nothing but the basic principles. And one should understand there are additional principles which have to be followed. So what are those additional principles? Additional location principles. So one should understand that a datum should be established before we do the cutting operation or any other operation. So datum or reference surface should be used. So where will the datum come from? So the datum comes from one of the surface of the workpiece which is properly machined. Next, for ease of cleaning, these locating surfaces should be as small as possible. Locating surfaces should not have, or rather, should have provision for holding swarf. So stop the misalignment of the workpiece. Similarly, burr relief or swarf relief shall be provided. Next, locating surface should be raised above the ground. Sharp corners should be avoided. Adjustable type of locators should be used particularly on this rough surfaces. Next, locating pins should be easily accessible and visible to the operator. Next, we shall talk about the clamping. So when I mean by clamping shall stop the remaining of XYZ translations which locating system has stopped, or rather could not stop. So in this process, it will exert a pressure on the workpiece against the locating surfaces and hold them in opposition to the cutting forces. So that is what a clamp shall do. Let us look to the principles of clamping. So the first principle, the clamping pressures must be applied against the workpiece. This should counteract the tool forces. Similarly, clamping pressures should not be directed towards the cutting operation. Whenever possible, it should be directed parallel to it. Next, clamping pressures must not only hold the workpiece, but should never be great enough to damage, deform or change dimensions of the workpiece. That means the clamping pressure should not cause any damage to the workpiece. Next, the clamping and the cutting forces should be directed towards the locating pins. So the cutting force, clamping force, they should be directed towards the fixed stop. అలా కాకుండా ఇంకో విధంగా ఉందనుకోండి, the tool forces, if they counteract the clamping pressure, the workpiece will become loose and it will get detached and slip away during any cutting operation or any particular operation. So this is not appropriate, but this is appropriate. Look. Next, clamping should be simple, quick and foolproof. Complicated clamps lose their effectiveness as they wear out. Movement of the clamp should be limited so that the idle time is reduced. Lifting of the clamp by hand is to be avoided. Wherever possible, springs should be provided. Next, clamps should never be relied upon for holding the workpiece against the cutting force. The cutting force should be arranged against a fixed stop or substantial part of the fixture body. Next, clamps should always be arranged directly above the points supporting the work. Otherwise, distortion of the workpiece can occur. That's not expected. Next, fiber pads should be riveted to the clamp places to protect the workpieces from getting pressed by the clamping pressure. Next, clamp should be able to deliver the required clamping force when you are operating with even the smallest force. That means there should be a sort of force multiplication option, right? You can find some diagrams here, three diagrams. The third one is the best diagram, where you can find the workpiece is supported between a locating surface, and from the top you are stopping it or clamping it by using a screw. If you use one screw in the middle, so it is going to bend in the middle. Same way, use two screws at the other side. So the workpiece is not going to bend, but uh, so in this case the workpiece is going to bend. Huh? So if you look to the third case, where workpiece where the clamps are being pressed just opposite to the locating surfaces. That's a perfect clamp. Next, clamps should be strong enough to withstand the reactions. Clamping devices. Simplest type of clamping devices are clamping screws. Just by using screws, we can clamp the workpieces. Next, hook bolts, lever type of clamps, bridge clamps, or strap clamps. So bridge clamps are very popular type of clamps. So how do they look like and what is the purpose? You can see here. So this is a bridge clamp or a strap clamp. If you look to this bridge clamp or strap clamp, it is a very simple and reliable clamping device. Clamping force is applied by the spring-loaded nut. So the strap proceeds over the workpiece. So one side you have a pillar or some support. So this strap, once it covers on the workpiece, the bolt above shall be tightened to clamp the workpiece securely. Right? We have different type of straps. So there is another type of clamp, which is a modification of the uh, strap clamp or bridge clamp. So that is heel clamp. You can find that. So this material. Uh, so this act as a heel. I mean the bridge pillar, instead of a pillar we have it as a heel. That means it is an integral part of the heel is an integral part of the plate. Right. So this is how we rotate to unload or load the workpiece. Rotate to one side, remove the workpiece, put a new workpiece, push it inside. So this is the heel clamp. So this is the swinging or latch clamp. This is also a type of latch clamp, but it's a quick acting clamp. That means you can operate it in a shorter time, complete the locking, carry out the machining, and release the workpiece in a very short period of time. So toggle clamp, this quick acting clamp, they come into the category of quick acting clamps. Okay, now we shall talk about the design principles which are common to jigs and fixtures. The first one, we should understand that we should be able to reduce the idle time to a minimum value. The basic requirement is reducing the idle time. Jigs and fixtures should be easy to operate. They should have quick loading and unloading features. They should be as open as possible to minimize the chip or burr accumulation. Next, they should incorporate foolproofing. So, on account of use of foolproofing, the incorrect loading of components shall be eliminated completely. So, a body when it is incorrectly oriented in a jig or fixture body, it will not rather complete the location, or rather the location should prevent incorrect loading of parts. Next, clearance. Clearance is provided to provide for for variation of component sizes, particularly the castings and forgings, to allow for hand movement so that workpiece can be easily placed in the jig or fixture and removed for after machining. Next, jigs and fixture should be body should be sufficiently rigid so that the tolerances are met with. Next, troniers should be provided for loading the heavy jigs and fixtures. Therefore, likewise, eye boards, wings, lifting lugs, means of side loading, unloading by sliding. So, this type of options should be there for handling the jigs or workpieces properly. Next, bur grooves should be provided so that the workpiece will be properly seated. Ejectors should be provided. That means devices for removing the workpiece or just pushing out the workpiece should be provided. Accordingly, you should have means for pedal operation or hand operation with levers, so that the workpiece is easily removed from the jig or fixture body. Sharp corners should be avoided. Sighting surface should be provided. Bolts and nuts should be inside the body. So no projections should be on the jig or fixture body, so that there will not be any injury to the operator. So next we shall talk about the drill jigs. So here we have to talk about the difficulties in drilling operation. So when thrust force is applied, see, one should understand that the two component forces in drilling are the thrust force applied along the axis of the drill. Another force is torque. So the problem with the drilling is if the drilling is straight away started on any workpiece, there is a possibility that drill bit shall be bending and it will try to wander on the workpiece. Instead of cutting at a particular place, it will go deflected and it will wander or rotate on the workpiece. When the force is at least sufficient by then the workpiece, the drill bit shall start cutting at a particular place where it is soft enough and it will continue the hole. So all these situations will lead to a sort of inaccuracy of the component produced. Likewise, there is a possibility that the drill breakage will take place. So to avoid these two problems, commonly center punching is followed, which will also create a room for the drill to travel and help in avoiding the thrust dissipation. Thus, hole shall start quickly. On the other hand, if you have a jig, a guiding bush, so that guiding bush will prevent bending of the workpiece, and therefore the concentration of the thrust force will be there on the chisel edge, and drilling shall start quickly. Once the drilling has started, there is no problem. The process will further continue. The main cutting action shall be done by the primary cutting edge, and of course the secondary cutting edges are also going to help this cutting action. So we shall look to this drill guiding elements or drill bushes. How does this look like? Simply, this is nothing but a hardened thalam. Correct cheppalante, So these drill bushes, which are nothing but the drill guiding elements. So these are nothing but the hardened collars. So these drill bushes are nothing but hardened collars fixed inside the uh, surface, plate or body of the jig through which the drill bit shall proceed. So there are different types of drill bushes. So headless bush, we don't have any head. So simply they are press fit. Likewise, headed or flanged bush. So the top of the bush is going to have a flange just to secure itself properly on the jig body. Next, there are bushes which we call them as renewable bushes. These renewable bushes are also fixed renewable bush and slip renewable bush. Whenever you require the guide bushes to be replaced periodically because of the wear of the inside diameter of the bush, in case of large batch production, replacement is simplified by using a renewable bush. So once sufficient number of components have been produced, even the the bushes have to be replaced frequently whenever I require to carry out some other type of operations, or when this inside bush is worn out, I go for renewal bushes. These renewal bushes are also fixed renewal bush and slip renewal bush. Fixed renewal bush, so this renewable bush can be replaced when it is worn out. Right? We have this screw facility. We can loosen this screw, this retaining screw, and we can lift it up easily. Slip bushes. Slip bushes are referred to as liner bushes. Of course, sorry. The slip bushes are used when we have more than one bushings are required to be interchanged in a given size of the liner. When two or more operations are required, I have to go for such a situation. When drilling is followed by reaming, counter boring, mathematically for every operation I require to remove. So such type of bushes, we call it as slip renewal bushes. The hole is first, for example, the hole is first drilled with a guide bush of requisite inside diameter. After this bush is removed, and another bush to guide the reamer is put within the liner bush. Screw bush. What is the screw bush? It's a type of bush which can be screwed inside the jig body. That means we secure it in position by screwing up. So by doing this, it can also give a clamping pressure also. So there is one more advantage with this screw bush. Liner bushes. So when I mean by liner bushes, I should recall the renewable bushes. So inside the liner bushes, the renewable bushes are located. Next we have special type of bushes, long bush, extra long bush, bushes where holes are drilled to be close to one another, and a bushing with two holes. So these are all the different type of special drill bushes. We shall now talk about the different types of drill bushes, drill jigs. The first type of drill jig, we call it as template jig. It's the simplest type of jig. It is simply a plate. It is almost same as the type of job which we wanted to actually make. Simply this simple plate, which we call it as drill plate, template, it is put on the workpiece and the drilling is carried out. You may notice that even bushes shall not be provided. Right? The plate itself should have the holes which should be hardened. The next type of jig, it is called as plate jig. It's an improvement over the previous type. In previous type, we have seen that It doesn't even have bushes. Huh? Even no bushes. Huh? And where this I'm still talking about the template jig. So here we require, or it is almost same as the workpiece to be obtained. Better have hardened holes. When we talk about the plate jig, in this case we have drill bushes extra. Therefore, it is an improvement over the template type. So drill bushes are provided in the plate to guide the drill. The workpiece is clamped to the plate and holes are drilled. Next, open jig. So this open jig, I can sometimes even call it as a channel jig. CHA channel jig. So it is a channel jig. You can find that the workpiece, the jig body is simply a U type of channel, and we have arrangement to simply push in the plate which contains the drill bushes and clamping arrangements. Next, swinging leaf. So in the swinging leaf, it is possible to lift up this latch. This latch can be lifted or rather rotated about hinge so as to load the component. Once the component is loaded, you can use this clamping arrangement just to push the workpiece against the jig body. So this type of jig we call it as swinging leaf jig, or it's simply a swinging leaf jig. Next, box type of jig. I use it. I mean, the holes are to be drilled in more than one plane, right? So we have bush plates to different sides. Bush plates to different sides. So along with the drill bush plates, we shall have number of feet. So bush plates and feet, they are available so that the uh, body can be oriented conveniently to the machine table face, such as a drill post. So in this diagram, you can find uh, in position 1, hole 1 is made through this drill push. Next, you can find two more holes. So what I do is I rotate the workpiece. Say I write it 1. So this is 2, this is 3. So 1 hole drill in step 1. 2, 3. These 3 holes drilled in step 3. So what is the step 2? Rotate jig by 90 degrees. Right, so this is the special type of jig which we call it as box jig. One more type of jig, a famous type of jig, which we call it as post jig. So in this post jig, we call it as post because one of the locating elements is nothing but a post. ఇక్కడ కనిపిస్తున్న మనకు సెంటర్ ఎలిమెంట్ ఏంటి అంటే simply a post. So this is post, locating post. Likewise, we have guiding elements and clamping elements. Just a minute. Okay. So let us look each of the elements. Element 1, 2, 3 like that. So jig body, element 1. Next, locating elements. So clamp, we find here post. So that is locating element 2. Locating element 3 is also available. So that locating element 3 is nothing but your diamond locator. So this is another locating element. Next, clamping element. So the clamping element is C washer. So put the C washer over the post and tighten the nut with the hand. That is enough. So that is nothing but the clamping element. Once clamping is also complete, then we can talk about the guiding element. So ఇక్కడ bush and guiding element. Number 4. Next, these two are nothing but the feet. These are nothing but the elements to fasten the jig body or position the jig body on the machine. ఈ legs మీద కూర్చోబెడతాం. Right? So these are a typical example which shows almost all the basic elements of jig. So this is a fixture which is nothing but a turning fixture. So two views are there. So the workpiece is nothing but a plumber block. So we find workpiece, a plumber block. So I have to fix the workpiece in a proper way. So for that, what I am doing, element 1. So this is the element 1. So jigger fixture body, so which includes a plate, something like an angle plate. Next, element 2, locating elements. So we have different locating elements. So you can find a diamond locator here, and it is a principal locator. So these two are nothing but the locating elements. Next, how to hold the workpiece. So we have clamping elements. So bridge clamp is there on this side and from that side. So both of them would keep the workpiece in position. Next, you can find one counterweight also, just to see that the object is not causing too many vibrations or bending of the check body. And of course, this eliminates the possibility of vibration. Next, clamping. You can find a bridge clamp. So this can show an arrangement which we call it as clamp. Right? So this will almost complete the jigs and fixtures. Of course, we should talk about the quick acting nut also. What is this quick acting nut? So this quick acting nut is a type of quick acting clamp. How does it act quick? We have to look to the construction. Only then we can tell how it works. So unlike the normal hole inside this nut, it shall have an inclined hole. It shall have an inclined hole, so through which the workpiece passes, or rather we push this when we want to operate it. So how we operate it, please see. we push the nut by putting it in inclined position. Then after reaching the end, we shall try to rotate the quick acting nut and then tighten it. Right. So by rotating the workpiece only by half a turn, it is possible to clamp the workpiece. Okay. So this is a complete discussion on jigs and fixtures.